Okay. I know there's a lot of information here, and it's hard to remember everything, and things change so much, and version to version and things like that, that it's hard to document everything, which is why I started recording everything to begin with, so that everybody didn't have to do like they do in an X-Ways class, furiously write every single note down and do the whole thing. So you get this so that you can rewatch it again later on if you're sitting down with a DeepSparse in your office and you're like, I know he said something, I can't remember what that was. You can go back and watch the video and go through that piece again. And so at least from that standpoint, that's one of the reasons why I do so much, is that if you have the video, you can always re-review it, watch as many times as you want later on. I know that's hard to do because you're here and then you go home and you got to spend another 10 hours watching video or whatever, but that's constantly how I'm learning stuff. I'm doing it by repetition, going through it again, seeing what he said, seeing how you go over whatever it is in videos, which is why YouTube has become such a great thing for me to learn how to fix a air conditioner or something like that from. So, taking a step back to all the things that we can do, one of the next important things that I would have done is looked at the heads. If a drive wasn't responding correctly, but I had made it this far, I'm into it, some things are green, some things aren't, they're failing, and I'll create a failure. We'll go through something that'll make that happen. But it's hard to get bad drives that will survive the entire process. And you'll make some. You'll be making them today. So the important features here is that I can test my heads individually. Now there are some things that you sometimes have to do, like a Seagate hard drive has a serial port on it. And for the DeepSparse on older Seagate hard drives to work, that comes with a cable, and the cable has to be attached to 2 pins on the back of the drive. And I've documented those. They are in the book. However, as a whole, you've got to do it with that cable. The new Seagate hard drives can be done through the standard port, just like I just did. Like I don't have a serial cable hooked up to this Toshiba. And when I say serial, I don't mean SATA. I mean an actual true serial port, which is your old style UART 32s, things like that. So they have a special cable that has to be hooked up. So in this case, on this particular Toshiba, I did not have to do that. It figured out the zone tables. It did that on the fly. And just so you understand, it's not actually modifying hardware in any way. It's doing this all in the DeepSparse, storing this data in that area on the destination drive about your configuration. And if I took this Toshiba to another machine after I said turn off a head, it'll work fine. All my heads will be on, it'll all be fine. It doesn't do it permanently. The only thing that does it permanently is a PC3000. You can do it permanently, okay? All right, so now I showed you the media test. I'm going to rerun on the source drive the media test again now that I've done heads. And you'll see I will now have 4 individual tests that will run over each of those drives, over each of the platters, and tell me if a head's working or not. So I may have read the system area, I may have made it this far, I may still be having some problems where some things don't work. My thing is to know, do I have a bad head? And usually what will happen is if I get red, if one of these, let's say head 2 was red all the way across, I'd be like, that's probably bad. I'm going to have to replace that head in order to read anything from it, but maybe the platter's scratched. I don't know how bad it is right now. So the first thing I would do is I would just, even maybe before I've ever opened the drive or done anything, I would just turn off the bad head. I'd read all the other stuff, so at least I have something. It may be the last thing I ever see, because no matter how many times I say this, you can replace and fix drives. As soon as you do start taking parts out of drives and introducing new parts, your success rate goes down. I know that's what we're going to do all week, but the best thing I can tell you is hard drives almost never do the same thing twice if they're damaged, so take advantage of the one time that you see anything. I'd be very careful about unplugging it, moving it to another machine, even maybe turning it off if I could avoid it. I want to read what I can that's good, and once it came up, it may be the last time you ever see it. It may never come up again. So take advantage of that. If you always do that first and you never hesitate knowing that it's that bad and you have something critical on it that you want, then, what if this was a Bitcoin wallet? That would be important to somebody, right? $80 billion in Bitcoins. Anyway, so you can turn them off. I'm going to show you there is a screen for that. You don't have to put 2 and 2 together quite yet at this point. On the imaging menu is all the control mechanisms. And there is an item called image process. So this is part of the process. If you're going to turn off a head, it's a process. So now you'll see on the bottom, normally this space is just blue. There's nothing there. Once you've processed heads, however many heads that you have, will show up here with checkboxes. So now this screen is a process. This is all about, I'm going to do the whole hard drive, and these are the passes that I'm going to make. So I can do a pass, I can make them be whatever I want. They're just text names. They mean nothing. I can make them whatever I want them to be. If you are going to process anything on the hard drive, even if you're going to manually run something, it must be in the list or it will not process it at all. Okay, so you must add something here. Right now, these are the only 2 passes I can run. There's like 8 of them that are available, but I can't run any of the other 8 if I don't put it in the list. Okay? Does this make sense to people? I'm going to give you an example real quick. We'll come back to this screen. If I hit F5, you've seen me do this. I can go to a position. I can say from 0, execute a pass. And so this purple box right now, there's only 2 I can run. Fast primary and secondary. Those are the only 2 I put in the list. But there are others. See, like here's one called data retrieval. They used to have an error, and the error would pop up a little red box, and it would say something like pass of the index isn't in the limit or something like that, something stupid. And I complained about it, and I said that no one knows what this means. And so it just pop up a box and it would die, and no one would know what they did. Now what it does is it says you are too stupid to use this machine. So what happens is it says the error in the log and then just runs its own passes that are in the pass. So when I now say run data retrieval, it won't pop up and stop. It'll say an error, and it'll say this is a different error than it originally said, like they reworded it, like that, like they couldn't reword it and go, you chose the wrong pass. Like that would have been nice and easy. But, they're Ukrainian, and it's hard to tell, I guess, maybe what the English language means, but error, index of the current pass is over the limit. No one knows what that means. There's only 2 choices I could have selected. I chose something that wasn't in the list. So it is running. It's doing something. It just said I'm too stupid, and it went on anyway. But it started at pass 1. So it's now running pass 1. Does that make sense? So if you choose anything else, if I want to run a different pass, if I want to hit F5 and go execute something, there's a whole pile of these. Like I cannot run any of these unless I added them to the list. Everybody good so far? That's it. It's just a simple limit. Then this box, overwrite LBAs on destination for unretrieved sectors. This happens, so imagine you did a hot swap and you have a serial number from a different drive. When the DeepSparse images it, it keeps track of that serial number so that if you brought a drive back that you touched before, it knows that these 2 drives are married together. But there may be a time, because that hot swap didn't work, that used a hot swap from another drive. So now I've got a mixture of 2 different images. You may have a situation where you don't want to overwrite the data you already recovered because the DeepSparse is going to think it's a new drive and make a whole new map. And you won't see the old map anymore. It'll be gone. But you recovered data and you got like 80% of this drive. So you only want to focus on a new set, but your old hot swap died. Does this make sense to everybody? So you've got an overlap of 2 things, and I don't trust it anyway. What I would have done if that had happened to me and I said, oh, my first hot swap died and it no longer works, but my new hot swap drive died or is alive and it works, and so now I'm trying to make, do you understand what I'm saying? Mm-hmm. Then I'm trying to make 1 drive out of 2 drives is what's happening now. That's what's happening. So I would still clone that drive. I would save it. I would say I'm going to take my destination drive. I'm going to come over here. I'm going to use Surprisingly, I use in-case files a lot because they're compressed. So I can save an image of a hard drive and then come back to it later. So if I want to be protective, I'm just going to do that really quick. I'm just going to take that to another machine and image it and protect the copy I already have, because once something happens to that copy, you don't know you can get back to where you were, or you need to see something. So I'm overly protective. If anybody ever says, well, I need to do this, but I'm afraid, well, then image that and then do it anyway, and then have the copy you can go back to. So I'm way overly protective. When I'm done, sometimes I'll have 16 copies of something, and then I'll go through them and figure out how to merge everything together. So I'm just saying, don't eliminate that factor. You can make an image of your entire drive and then just come back to that later. Okay? As far as the DeepSparse is concerned, it's just data on the drive. It doesn't mean anything to it. And you can always process that another way. But you need to have that data. All right. So that's what that's for. It's basically to stop you from doing something like that. But I'd be overly protective. And then the other stuff are things like Germany. Power is important, and they're very eco-friendly, and you've got to turn it off or it costs you money. So they have power off processes. And then they do have the dummy process, which is called wipe unprocessed sectors at the completion of the drive. So let me point this out to people. I have a 100 gig drive, and I copy that to a 200 gig drive. So now the 200 gig drive has 100 gigs in the first portion of it. The second portion has what? What's in the rest of the 200 gig drive? 4%. Yeah, 4% of the DeepSparse, and then what? What else is there? What?
Anything that was already there.
Anything that was already there. So the last recovery I did might be some pictures of some guy's wife on their vacation that he didn't want anybody to see. And so you don't want to accidentally give those pictures to the guy from the first drive who they don't belong to by processing all that data. Does that make sense? So there's a wipe unprocessed sectors command that would happen automatically at the end. Now, I do it manually. I have a process I've been doing for 20 years, so I have a process that I always do. So at the end of every recovery, before I disconnect it, that's my key. If I'm going to disconnect the source drive, the destination drive from the DeepSparse, I have 3 things I do. I always do these 3 things. And I just manually know I'm going to do them. And it's so much so now, I don't even think about it. It's completely habit. And so I've got muscle memory that says I can't touch this unless I do these 3 things. And so I just always do that. But if you're not you haven't built this process before, you can do that, and then it'll do it for you automatically at the end. But you may never be done with your recovery. You may keep going back and getting chunks of it or working on it. And so that's why I don't do it automatically in the rest of the process. It just takes time, and then you don't know that you did it. But some people, they just do the best they can. They just hook it up, they let it run, and they grab the drive, and then they go get whatever it is that they've run, and they haven't double checked everything, they haven't gone through everything. So I'm just saying those are commands that you can do. Okay? And then if I want to turn off a head, we're to the heads, I just uncheck the box that I want. So I can literally come down here and I can say, I don't want to copy anything from head 1. Bam, I'm done. I hit F5, and you'll watch it as it copies. So now I remember it made a new character over here based on what I told you yesterday. So these are the heads as it's going through the heads. So you'll see it's just going to skip the head number 1. So it'll just fly right by it. It's just gone. It was there, it just went by really quick because it didn't touch anything. And you'll see that there'll be gaps where it's imaging. So as it's imaging now, so these colors are not as bright as those colors. So it does not have as much. It skipped them, and so there are white sectors in there. If there are errors, it'll change color, so other stuff. So these have not been completely copied. Does that make sense to everybody? So that's what that means. Now I can see them. I'm going to hit the home key. I'm just going to stop it. Any key that you hit that's not a pre-programmed key stops the DeepSparse from doing what it was supposed to do. The ones that are programmed keys that do something are spacebar, which skips. So I can automatically, if I'm imaging and I hit spacebar, you'll see I'm going to skip 1,000,000 sectors. So I'm just jumping through the drive. The other one is tab. Tab switches to the next head. I don't think it's documented. I think it's completely undocumented command. But when I hit tab, it'll switch from this head to the next head. So you'll see I'm just jumping through them really quick. It's kind of hard to see because they're all the same. But you can see I've jumped, right? So tab switches to the next head. It's kind of, the only time you'd really use it is I'm imaging something. You have to have a head map for it to work. It doesn't do it if you haven't created the head map. So you kind of already know if your heads are working or not. But if it's grinding and starting to make some brown squares and you want to see if it's just that and jump ahead, you can either hit spacebar and it goes a million, or you can hit tab and it goes to the next head. And so you can kind of monitor it, because sometimes you're going to live monitor it and make adjustments. You have to know what's going on in order to program it to do what you want it to do. Like, you don't have to just let it be dumb and do whatever it does automatically. You can manipulate it and make it really do its job. And that's what makes me better than most of the other people with it, is that I manipulate the crap out of the DeepSparse depending on the problem that shows up. And I'll make it and I'll test it and grind it on certain things till I figure out the best way to read it. So tab, jumps, heads. Those are the two primary things. I can't think of any others that right off the bat would do. Oh, well, there's 1, 2, 3. They're the commands that show the different screens. So 1 is the full screen map. 2, it tells you right there on the first one, press 1, 2, 3, ... And 1 is the full screen map. 2 is the data that's in hex. 3 is your heads and your speed. 4 is your average imaging stuff. And then there's an unread diagram which shows you percentages. That's all they have so far. It's just those 6. So I generally, other than staying on 1 just to see if the whole image is copied, I prefer to be on number 2, which gives me the content in hex. What I'm looking for when I see content like this in hex is I almost always, as soon as I start imaging, stop the imaging process, or depending on the type of error that we have, I hit the home key. It takes me to the very first sector. The very first sector is the key to all hard drives. The very first sector, even though we have switched to a new partition structure, so the original partition structure was called an MBR. It's a single sector. It is the master block of the whole thing. It tells you everything that you need to know, and it's your master boot record. Okay? So your master boot record keeps the boot location of the data and then a partition structure and how big the partitions are. And so that is telling you everything about your drive and the content of the drive. So the very first sector, we only are looking up. There's 512 bytes. But in this little window, I can only see a small portion of it. You'll get used to seeing this. This one's a bootable drive. If it wasn't bootable, sometimes all of this is 0. If it's a GPT structure, generally this will be 0. But even with GPT, it sometimes clones its first record into the MBR, but a GPT will also always have, which is ironic in and of itself, it was never supposed to happen, 55AA. At the end of the first sector on every hard drive that is a Windows hard drive, it will have 55AA, and consequently, because Windows did it, everybody else did it too. So Macs, only for 4 months, did not have 55AA. From January of 2006 until April of 2006, they did not put 55AA in the boot sector because they didn't boot Windows. That was an add-on that happened after hackers started hacking the crap out of the ROM, because when they switched to an Intel processor, they said, we're running Windows on your machine. I don't care what you say. And they hacked the crap out of the ROM and they made it work. So Apple finally said, all right, we'll give you that because we don't want you hacking our system. So here's Boot Camp. And we gave you a tool to do it. And Boot Camp synchronizes, and portion of it, there's another thing called refit, and it synchronizes your data to the boot partition so that you can have a bootable drive, because it's required for most of the Windows systems. The 55AA, so I'm on the first sector. F3 is view. Now, across the menus, help is the first menu, which help is nothing. Help is, hey, this is all the stuff I own, and if you want to talk to us, go to this website. That's it. So basically it's your version numbers, your serial numbers, and then all the modules that you have, and then you can call them or whatever. Not even a phone number. Then The next menu is the View menu. So you have two options. I do have network on the machines. It is not active. But normally it would just be, I have IP addresses and blah, blah, blah. How many packets in and out? No big deal. Okay. View sector. Whatever sector you're on, it'll give you the full 512 bytes. You will do this all the time. F3 will become your friend. F3 on this scenario, immediately the very first thing I do, because this might be 0 if you're on GPT or a non-bootable drive. So if it's an external hard drive, it's not going to have a boot structure. It's just going to have a partition structure in 55AA. On GPT, you may just have 55AA. All of that is important because those tell me things right away. But generally speaking, I scroll down to the bottom. You get past all this crap that's the invalid, blah, blah, blah. This stuff is the stuff that's just telling you I got a problem. So boot, and I got a problem, don't boot me, whatever. And then this is where the meat and potatoes happens. There's enough space in these records going backwards from the end. You will see this is called the Partition Signature. So that lets Windows know I am a Windows drive, mount my partitions, and start that whole cranking through thing that says auto mount and look at my files and then mount my partition. If 55AA is not there, it will not mount it. Windows will not mount it. It does not mean you can't do a data recovery. All of your software will see all of the stuff just fine. Windows is the only thing that won't mount it. Thank God, because that's where it messes up. If you mount a only partially copied drive, I've only copied part of this drive. If I put this on a Windows machine and 55AA is enabled, then it's going to try to mount the drive. It's going to start looking at files, and if they're incomplete, Windows can blue screen. You've seen it happen all the time. You plug the drive in and bam, it blue screens. What happened? It doesn't have something that it needs that is corrupt. Windows doesn't know how to process the data, and rather than being rock solid, it just blue screens and crashes. Right? You guys have all seen that. And then what's it going to do as soon as it reboots? What's it going to do first? What happens if Windows blue screens? What's the next stage? It's what?
System recovery?
It's not called system recovery. Yeah, it's going to say your drive crashed and I need to scan to see if there's any damage, basically is what it says. So scan disk runs through 3 phases. And those 3 phases, we'll go through them in depth tomorrow, but those 3 phases do damage. There is not one thing about scan disk that's actually good, except that if it deletes some corrupt file that's unnecessary, that your system will reboot. That's it. It's destructive. It does not correct it. It destroys it. You understand? So scan disk is your enemy. It is terrible. It should never happen. And after I tell you and show you how it figures it out, you're going to cringe because of all the things that should happen. It is not nice to those files at all. It just loses your files. It just kills them and destroys the data and any record associated with that data. So again, there's 3 stages. The way that Windows knows that your system crashed. There is a table in the MFT entries. The NTFS is a structure. Inside NTFS, there is actually individual records. There's 16 of them because of hex, and there's a chunk of them that are reserved. So 14 through 16 is reserved. One of the items in the list is called the volume information, and the volume information has the name of your drive and a artificial serial number that it creates at the time that you're formatting. And it has, and we didn't know this for years. We didn't know this till like maybe 5 years ago. There's something called a dirty bit that's where it's stored. We knew what the dirty bit was. We just didn't know where it was stored. It's in the volume information. And so what happens is when your machine boots, it sets a flag and says 1. And when your machine crashes, it never turned off 1. So then when it comes back up again, it looks at the volume information and says, oh, the 1 is still set, so you must have crashed. If you shut down correctly and you do this shutdown, then it changes the 1. As soon as it's done, it gets to that screen, it says wait, and then that's what it's doing is it's changing 1 to 0, and then it shuts down. So every time the 0 is up, then it's fine, and every time the 1 comes up, it says, I'm going to run scan disk. And it'll just run it at the beginning. So if you go to lunch, it crashes, it comes back up, it's eating your disk. So you've got to protect that disk. And surprisingly, a very easy way to protect the disk is delete 55AA. It will not change your data because Windows won't see it as a valid drive. I'll show you some more about that in a minute. But here's the next important part. This block right here, you can see there's a blank piece and then it starts. Here's your record. One of these, and I have to look them up sometimes because I don't remember every single one, but one of them's an active flag. One of them is the entry, and so you get 4 entries for your partition in an MBR. GPT can do 128. So in MBR you have 4, and that's it. It's primary partitions, or you can have 3 primary partitions, 1 extended partition. And extended partitions, I've seen them up to 72. You can just they just wrap each other inside of an extended partition. So it goes to the partition, then wraps the next partition, then wraps the next partition, but only the first one's pointed to in the hard drive. So when you're formatting your hard drive now, most people just choose 1 partition. Unless you're on Linux, then you choose 3. Right? Everybody good so far? Because your normal process is just 1. Most drives you will see will only have 1 or 2. And the second one that you'll almost always see is the utility partition. Like if you buy a Dell, it has like a little boot partition that you can click a button and you can say test my machine, and it comes up with this little interface in the BIOS looking thing, and it tests your machine. It's actually running off the local hard drive. So if you have a Dell and it had a utility partition, what you would see is, so there's this record, this is the first record, this is what is important. This position, number 7 right there, means NTFS. So the hard drive that is my source drive right now is NTFS. If this was a Dell, I would have a DE, because they use DE as their utility partition. They got really creative and used hex DE. Thank God that their name wasn't, you know, FU or something like that. So, but we've got DE. They wouldn't maybe use U. U's not hex. Anyway, so DE, and then the next row would have 07. So I'd see a Dell, and I'd know immediately it's a Dell, and then bam, it's NTFS. So I already know a lot about how I'm going to process this drive. I know what software I'm going to use. I know what the MFT is in my head. I know the layout of a basic premise of this drive, right? I know if I can process it in this. What if I see, and I have seen this, I've had things before where it's just a strange number. I don't even know what it is. I have to look the number up, but at that point in time I know none of the software I have will process that partition. So there is a list of these partitions. So if you guys remember, and again, I'm mostly these days the oldest one in the group. In 2008, everybody knew this stuff, but now I'm the old guy. So when you are processing, let's see who remembers this. Stop. Anybody seen the screen? In the old days, you would format your hard drive. You had to select what your partition type was. Now, Linux is mostly the tool that does this. Generally, if you want to format a hard drive, Linux will pop up some boxes and say, what do you want? This is the table of the original F-disk layout. So when you first were in DOS, and you formatted a disk. You did F-disk and then you did format. So you told it, I want a partition and here's what I want it to be, here's what I want to format it, and then it would high-level format it. These are your selections of all MBRs. So in all MBRs, these are your choices of file types and file systems. So FAT12, you can see here, which would be a floppy disk basically, and you'll see, number 7. And surprisingly, so again, HPFS is OS2, and that was their original partition structure, was high performance file system, which later became NTFS. So you've had a lot of tools over time that actually said HPFS, NTFS, and nobody ever questions it. Like, they're just like, oh, okay, well that's Windows, I'll mount it. HPFS was OS2, and then it became NT, and the only change was 17, the sector 17 changed, and that's it. So, and then exFAT uses the same symbol for a data partition, so you still get the basics for that. which is FAT64. Everything else you would see, as you broke it down, you would see, oh, if there was FAT16, Windows 95, and then Windows 95 OSR2 was number 2, then now it just went to 51. So you'd start seeing those numbers in that table. So I'll know right away when I'm looking at something, what am I looking at? And you'll get quick at this actually. There'll only be like 5 things you'll ever see over and over and over again until you see one you don't know. And when you see one you don't know, then you go down this list. Now, the first thing I do, if I see one I don't know and I'm not sure. Now, keep in mind, people made these up. If I was making a new operating system and I wanted a number, I would just choose whatever was the least likely one that you'd ever see. So amoeba, I might choose that and it'd be E1. But I might not really be amoeba. I might be something else. It's just nobody sees amoeba, so it's obsolete, or BOS, or something like that. Right? Everybody understand what I mean? So the first thing I do then is I carve for photos. If I carve for photos, I'll usually get the banner that would have popped up. Like maybe I don't know the file system and I don't know what it looks like, but I might get part of a picture or a picture, and it might tell me what it was. And it has happened a lot with some old Unix systems and things like that, that it tells me what it is by looking at a graphic that popped up. Okay, everybody good so far? So this is important from that standpoint. So I am looking at this all the time. I'm always looking to see 55AA, 55BB to see if it's there. 55BB is the disadvantaged version. Basically what happens is the DeepSparse came up with a method. Other people have too. It's originally in back in 1992 or whatever it is, when Dimitri wrote the original tool that he called MHDD, which is MyHardDrive's diagnostics test tool. He actually made a command in that tool that changes it to 55BB so that it makes it a poor man's write blocker. That's what he calls it. Basically, you flip 2 bits and then it changes it so that Windows will no longer mount it. So inside of the destination drive, because you're never changing your source drive, you don't change data on your source drive except for the HPA. You don't change anything else. All you're doing, so they made an item called Deactivate MBR. When I hit this button, it deactivated the MBR. I'm going to hit F3 again, and you'll see it changed the last characters to 55BB. This is only on the destination. It did not change the source. It only changed the destination. Everybody clear? So if you image your destination now with 55BB as that answer, you have made a change, and you need to document it so that you can tell somebody when you're sitting on the stand if that happens. So if you're doing forensics, that's what you have to. If you're doing data recovery and you're just doing your own, then you just made your drive only able to be read by data recovery software, which is great, because Windows is a rootkit of itself and you shouldn't be using it anyway. But we'll get into that too. But that stops that from happening. Now you'll see it knows 55BB is there, so it switched the characters to activate the MBR. Okay? So I'm going to show you, I'm going to activate the MBR again, and I'm going to put it back in its original state. Then I'm going to try to show you what actually happens in real life on a machine, because this becomes important. But you know enough right now to run the DeepSparse far enough, if you started doing a rebuild, that you could at least get through the first commands to get that far, and then keep learning about the DeepSparse as we go. So I'm going to try to add to that knowledge now, and then as soon as we come back after lunch, I'm going to trial by fire. I'm going to tell you as fast as I can how to destroy a drive, and then how to rebuild it. And then you're going to start that process, and that's going to go to the end of the day. Okay? And I'll be walking around helping everybody. Also, I have a friend who's taking this class who also runs data recovery and does an IT business. Her name's Natalia, and she's going to come and help out this afternoon as well, and gives you another person to talk to if you want to talk to somebody. And she's Russian. So from this perspective, what I'm going to try to show you is the effect that 55BB and 55AA have if I'm going to teach you some Windows things that people don't even know. I swear you will talk to IT people who've been doing this all day long, every day of their life, and they do not know this. Okay? So right now, I'm going to switch over, and I'm only going to do this on a Windows 7 machine because the DeepSparse, in its infinite wisdom, decided, even though it's basically a 32-bit tool, in the very last second of the last update, it became a 64-bit tool. Like, I don't know why, because it is the worst looking project file you'll ever see. Like, it's literally, their software does not, I feel like they're trying to compete with the Atolla. The Atolla is 100% 64-bit. There is no longer 32-bit or 16-bit anything with the Atolla. The Atolla is 64-bit only, and going forward will only be because of memory and other things that it needs. It's pretty advanced from that standpoint. But the DeepSparse is using DOS to boot on, and then it uses a Windows tool to look at itself over the network. You can look at the DeepSparse and control it from a Windows machine with a Windows tool over the network. You can also do it standalone. So I can unplug the destination drive from my machine, plug it into a Windows machine, and the DeepSparse can see itself as long as it has the right version. Okay? And I don't know if I have the right version because it changes every day. So I'm going to show you. We'll see if it's on fire. All right, so all I'm going to do now, I've set, it's 55AA. I've got part of this file system recovered. Not a great bit of it, right? Like, I've got all kinds of mess. I'm going to turn it off because I'm unplugging my destination drive. Okay? So it's gone. I'm going to switch to the Windows 7 machine. And I have opened the partition management tool, so the disk management tool. I spend a lot of time here. I think you guys should too, because when you're plugging and unplugging drives, you know how your system sometimes just hangs and you can't do anything? If you have this open, you can already see a response. But if you don't, and you try to open it after you plugged in a drive, it may not come up at all. It just hangs. It never comes up again. So I open it ahead of time. And so for those of you who don't know, the easiest way to get here is if you have My Computer on the desktop and you right click on it, you can say Manage, and then the Manage box pops up your toolkit, and then you can just drop down here to Disk Management. That's the easiest way to do that. Okay, I have two open, so I don't want to do that. Okay, everybody good so far? Now, when you're in this screen, first off, it's telling you, like, okay, so if I have GPT, I got something else going on, I got a utility partition, that's what mine currently looks like. And then you'll see all the other disks in the media that are mounted there, or what's supposed to be mounted there. I'm going to make this bigger. So now I'm going to show you what the effect is. I'm going to take my destination drive, and I'm going to plug this in, and you're going to see what happens. So, right now, this is the recovery that I was writing from the source drive to the destination drive. My source drive was 100 gigs. My destination drive is 320. Okay? Right now, I haven't set any geometry. I haven't done anything to make the two drives look identical. All I've done is just clone some sectors. Right? 55AA is enabled. Otherwise, it would not have mounted and shown me this at all. So it tried to mount NTFS. It looked at some tables in NTFS and said, oh, I have a volume name. And is the dirty bit set? And ironically, it thinks it's a healthy partition. I still, to this day, haven't figured out what they call healthy. Like, okay, I did mount my NTFS volume information. Outside of that, what do you know is healthy? Nothing. It has no idea. I cannot figure it out at all. There's nothing I can do, trick it, do whatever. If it doesn't, because it does a weird thing. If NTFS isn't is not intact, you never get not healthy. It never shows you not healthy. What happens is it mounts, and you'll see it blink. You'll see the name come up from the volume information, and then it'll say, oh, table's corrupt or something, and it'll say raw. And it just dismounts it and makes it raw. And once it's raw, you can't do anything. So I don't know what else is not healthy. There's no other not healthy. Oh, I'm sick. Yeah, there's no sick. I'm on my way to being sick. Like, there's nothing else. This is all there is. And it knows that I've set the active partition flag. So in the MBR, there is one number that's the number 1, and that's active. All the others will be 0. And that'll be active and not active. Okay? And then this is all the leftover space. The DeepSparse data is right here. Okay? So now I can use the DeepSparse tool. I'm going to show you the DeepSparse tool really quick. So I have added that in. So do not do that. So I have added this in. Another quick note is if this box is not open when you plug in the drive and it shows you the drive, if you open the box after you plug in a drive and it is not initialized, it will ask you, pop up a box and say, do you want to initialize? Have you guys seen that box? If you click yes, you have destroyed data. Never, ever, ever click yes. And the problem is you can click ahead of yourself and it will accidentally click yes, which is another reason why I opened this box in advance. Okay? I'm opening the DeepSparse Tool. The DeepSparse Tool is ugly as crap. It looks like an incomplete project file. I'm not kidding. However, it does have a couple of things it can do nothing else can do. You can change the flags on the data that you want to recover. You can specify a folder and get just a folder. Does that make sense? So here's how this tool works. I've got the hard drive plugged in, so it does show up in the list. This is my 300 gig hard drive. I've got access to the whole hard drive. I can see the data. So first thing I have to do is I have to create a stupid project file. So I have to give it a name. Like, you know, I know this is Francisco Pelamonte or whatever. Okay? So I'm making the client's name. It makes me a folder. That's all it does, is it makes a folder. It doesn't do anything else. It doesn't track what you're doing, and it does not keep track of the flags that you select. You have to manually write those down. I don't understand why they did this, but so I don't use it for that purpose. This list right here, if I was on a network and I had 10 DeepSpars, you can give your DeepSpars names, and they show up in the list. And you could select one from the network and control it. Okay? So I don't have any on the network, but I have one that's live. I have a real one. Okay? So this is the real one right here. I'm going to click on it. Now it processed data from the DeepSpar. So now these are the flags and the things that are in that area. So this is the stuff that I've copied or not copied. And so this is the map. So you can see I haven't copied some, and so on and so on. You can also look at them in hex. So I can do the exact same thing and come over here, look at something, pop it up in hex, look at it. Need a big window, so on and so on. Okay? I don't spend a lot of time here doing that just because it's so cumbersome for some of the things. So I specifically do one primary thing. I come to the File System Explorer. I see the partition that I'm doing. You have to ask it to process NTFS. So I'm going to tell it, I want you to look at NTFS and see how much I have. So scan the file system. There's flags inside of NTFS that say a file is deleted. There's two things that you need to know. The deleted files are the ones that have been kind of recently deleted. There's still an entry for. Unallocated is the ones that are far, far gone, and they no longer have a table entry, and you can only carve those files. So they don't exist as part of the system. There may be some data there, some random data that you have to extract, but that's not usually what people want. So I'm going to stop this. I don't care about the deleted files. I'm going to let it go. You'll see it processing the MFT entries over here, and so it's building me a tree of what I could recover. Now, keep in mind, I did not image the whole drive, and I did not do it perfectly. I just happened to have enough data for it to process something and tell me something. Does that make sense? I'll show you how to do the data complete, but there's a dot there, which means current directory. Inside of all FAT is started with FAT. FAT has an actual entry that's a dot, and the dot means current directory, and double dot means up a directory. Those are hard-coded into the file system. And it turns out, surprisingly, that if you wanted to recover data from FAT, all you have to do is scan for dot and double dot, and then scan to the next dot and double dot, and everything in between there is a directory structure with all the data. It's all together. So some tools do that. Incase does it. It's one of the few tools that does it correctly and carves out that data correctly. There's another tool called Get Data Back for FAT that does it correctly as well. Those two are some of the best tools for doing that process. So dot means current directory. So now you'll see this is the root of my drive, and this is what's there. So there might be some things that I want, like hot girlfriend pictures and things like that. When you're doing a recovery, versus a forensics job, it may be I only need payroll so that I can get payroll done very quickly. So I could actually select this and say only flag this for recovery, and then put it back on the DeepSparse and just recover just those files. It converts it to the LBA blocks, changes the table, and then from then on it will say I only want this directory structure. Does that make sense to everybody? So technically that would be all I have to do is I have to select this for imaging. It'll go and add them. It recalculated all the stuff that needed to be done there. And then the other one would be, in this case, documents and settings, Francisco Pelamonte, which happens to be on this drive 90% of the drive. Like there's not much more on this drive. I've made it specifically for this purpose. So it will add all of those things. And so you'll see it breaking all, look at all the fragments, all the clusters, all the files, anything associated with that. And the nice part of this is that, so you don't get the fragmentation problem. It actually finds the records, finds those folders, and creates, see I'm getting 77 gigs, which is out of a 100 gig drive, that's the majority of the drive. Okay? Everybody good with what I'm doing so far? If I was connected to the network, I did not need to unplug it and plug it. I could do this on the fly without ever unplugging and plugging it. But I had another reason to plug and unplug it. I'll show you in a second. So I can flag specific things. So I've now said I'm going to copy 75% of this drive. Everybody understand so far? Even though they made a project file and I should be able to say save, and it saved these settings that I did, it did not do it. It does not do it. It does not save them. I don't know why. It seems like a pretty important thing. I have to write down the trees that I did, because let's say I did not image, so I did not select this folder. I did not select default. And let's say default has a whole bunch of photos in it. Later on, if I'm using my tool to recover data and I come to the default folder and I had not imaged it, whatever's on the drive that I didn't wipe is either going to be zeros or it's going to be somebody else's old data, and it won't be real, it'll be chunks of data that don't make sense. And if I recovered from this folder, it would not be correct because I didn't image it. So, anybody understand what I mean? Any problems? Sir, good? Okay. All right. So now I'm just going to close this program. Yes, close this project. And then this drive is mounted. It is physically mounted. So in this case, I do want to dismount this drive only to preserve changes. If I did not have 55AAB there, AA, it would not have mounted it, so I could just unplug it. So right now, I'm going to take this drive. I'm going to come back over to the DeepSparse. And I'm going to reboot the DeepSparse. I would not have had to do that part if it was connected to the network. I would have just, but in this class, it's a lot of work to build it as a network, and there's some advantages for me showing you how partitions work. So once this comes up.
So what it did was it put into binary data at the end of the drive?
That's correct.
Okay.
It completely flipped all the flags that it needed to, and to specify specifically the data that I wanted.
And they couldn't take it from there and put it back into the program?
So I took the drive off, I put it on the system, and I created this project file, and I did this. If I was live on the network, what you would do is you would select for imaging, and then you would say go. And so while it was live, you would never have closed the program. So it would know those were checked. And it would recover the files and then copy them over the internet to your local machine. So as I selected for imaging and I said image those files and copy them, it does both steps. It actually tells the DeepSparse image the files and then drop them over the cable to my local directory. So it would actually do that process. It takes a little bit more time because you're not just doing the drive and then it's coming over the internet, it's coming over TCP/IP, and it's coming through DOS, a DOS driver, right? So that's the whole point. See, there's my drivers. These are my Ethernet drivers. So 16-bit. So I'm going to execute it. So that's the only reason why probably is that people are doing it live. And it's not a problem when you do it live. It's only a problem if your machine crashes, because then you lose your directory structures or whatever. But most people know, like Chase in my office, who does a lot of the, Chase been working for me for like 6 years. He knows every button he ever clicked. So if he's looking for something, he'll know what folder structure he was trying to get back for the client. So it's only because I did this live. So I got to start my machine back up. I got to rescan again. I got to get back to where I was before. So I got to get my drive running again. Then I go in to go do the imaging. And then now it knows where I left off. And then when I hit F5, I'll have an option that is, I missed a step in the process only because I was trying to do this live to show you the partition. There's a select imaging area. Remember I told you I didn't have all the MFT entries? Well, in order for the DeepSparse to really process the MFT entries, I just got lucky that I had them. What I would normally do is you have to select your imaging area ahead of time, because this view is data. It's something they added on later. And you're processing data, so you would hit this button and it would ask you, it would say, hey, I see a partition. I went to the beginning of the drive and I know you have a partition. This turns on a flag. And so now I would say, well, I would like to just get my MFT entries. Now there's three things: files, the folders, and then this is allocated or unallocated space. It's a bitmap that says these files are allocated, these files are not, and it's literally a map of bits that says cluster used, cluster not used, cluster used, cluster not used. And you'll see it happen. All of them in the beginning are all used. So the beginning will be F, 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 F. So they'll all be Fs, because it's a bitmap. If all the maps are on, 8 bits in a byte are on, it's an F. So you got 2 bytes, so you have 2 Fs. Everybody okay so far? I'm not going to try to teach you hex. I'm not going to try to go through all of that. You may eventually want to sit down and spend some time with hex to figure that out, but as a whole, 8 bits are in a byte, and they can be 0, 1, 0, 1, 0, 1. And if they're all on, they're all an F. And then 2 Fs, because there's 2 bytes for every pair. So I'm going to load it. This would give me the MFT complete. So it's looking for the MFT table. It went and found it and loaded all the files. Then it went and found the bitmap. Now I got lucky, I already had it. So that's why you didn't see a lot of action happen in there. If I did this, if I cleared this and pretended it was all brand new again, you would see it look for file records, and then it would look for MFT records, and then it would flip this up. But you'll see I have 74 gigs on my drive. And then after I've done that, you will see I now have a bit that's flipped here called image selected area only. So now this would have been the flags I just selected. So as soon as I came back and plugged it in, I would normally have this button would be on. It happens to also be equal. They're the same at this point. So when I hit OK, you'll see it will start imaging, and as it goes through the map, first off, anything I had that was green won't be touched again. Anything that it reads, again, as it goes through the process, you'll see now all these checks underneath. All those checks underneath mean it's part of the allocated space. It's part of the MFT entries that are all allocated. And so it does it by cluster. So you do get cluster slack space. You get that extra junk that was blank space at the end of a file that no longer is used. It still recovers that. But it will not do any clusters it doesn't need. Okay? Yeah.
So if you had a head turned off before you started this, would it turn the head back on, or like what would it do?
My answer should be no, but since you bring up a good point, it did not turn it back on. So, because this process should always be the same for whatever you manually have set, because that's a control mechanism. Like, I know I have a bad head, so even though I have this, I'm going to get all the allocated space. So in the map that I showed you yesterday where I said there's green and here's red, if I got all the green, so I could manually do exactly what that map said. I could manually say, ignore head 4, turn that off. Go read the MFT entries. As long as I have MFT entries that are intact from all of those other locations, wherever they point, I would get the answer. So I literally set that up in this process. But you're right, it would be, because in order for this to work correctly, I would want to have this head on. But again, if the head is dead, I'd rather do what I just did than have that be the issue. Does that make sense? But you are correct, anything you set up ahead of time. Most of the time I would have already been in the discovery phase before I did that process. So I would have already been there, like, can I get all the data? What's my problem? Let's turn off the heads, let's test the heads, and get through the whole process. All right. Everybody understand what we're doing so far? Any problems, any questions? So this would just now be doing allocated state. When this is done, I could take this to any software, find Francisco Pelamonte's user directory, and right-click and recover all of the files. I could not go to this Windows System folder and recover those because it did not select them. Does that make sense? Everybody happy with that? Only what I selected. So that's why it becomes very expedient to try to figure out where the data is and try to get the specific items back. Now, there's one caveat in the middle of all of this that you have to also pay attention to, and that is this thing. So the next piece of what I would tell you is from the book from yesterday that we still didn't move on from. We're kind of half and half on both days. Host protected area. Now, a host protected area is a very, very simple thing, but it can be very complicated if you let it be. You're cutting off a piece of the drive. That's what that means. You are literally, this is page, if you're still looking in the book and you want to make notes or do anything, it is page 196. All right, so a host protected area has some primary commands, which is how big is my device? How big do you want to set it? And what is my native setting? So there is basically a request that's all about LBA blocks. It's all about how big is my drive, and do you want to set me to something else? That's all it is. It's an agreement between the hard drive manufacturer and your motherboard. They have to agree, and they all do, because Intel forces everybody to do whatever they want them to do, and including AMD. You know who made Intel chips before they made their own chips? AMD. AMD was the company that Intel had contracted with for like 20 years to make their chips. And then when they uncontracted with them, AMD makes their own chips. So anyway, the whole point ends up being that there is an agreement between your hard drive and your motherboard that says, if you tell me I am so big, how big am I, then you must accept it. Okay? So a host protected area is the ability to chop off a piece of the drive and use it for something else. It was created by Gateway. Yes?
So the ADA secure erase command, will that go through the host protected area, or will that leave it alone?
Yes, it goes track by track and ignores all the settings in the drive.
Okay.
So now, again, anything that you need to verify, you need to do yourself, because I will tell you that code is sometimes not up to date correctly with some devices. So if you're expecting it to do something, double check it yourself. And once you find a brand and a model that works the way you want it to, then that's what you stick with. But generally speaking, it is supposed to do that. In all of my tests, it has. That doesn't mean in all my tests it ever will, because I have seen them do weird things before for other things. So again, millennials are writing the new code, and you don't, huh?
Don't look at me like that.
I'm just saying, there's a new set of people who did never know any of this other stuff, and they know none of the history of why things are, and so they're writing new code, and they've never used a calculator with red LEDs. So anyway, so the point is, this command was created by Gateway. They went to the ATA command committee, and they said one thing. They said, you know, every time we box up our computer and we ship it to you, we have to put a whole pack of CDs and DVDs in this machine, in this package, that we've had to make or buy, and we're sending them to you in case you ever need to restore your computer. Well, we don't want to do that anymore. What we want to do is we want to store them all on the hard drive. So we're going to steal space from the user for a very precious hard drive that they bought. Because remember, this is like 1996 or something that this happened. We're going to steal precious hard drive space from the user, create a special area they can never erase or get to, and we're going to store your CDs and DVDs there, and then later on we're going to pop up a box that says, hey, I know you have this new machine and someday your machine's going to crash. You should probably write your DVDs, CDs out to something